Case study: AI in cybersecurity, revolutionizing threat detection and response in the digital age, a multi-case investigation. AI's integration into cybersecurity frameworks has revolutionized the field, offering unprecedented levels of protection against emerging threats. The case of a multinational corporation, Technova, serves as a compelling example. Technova, a leading technology firm, had been experiencing frequent distributed denial of service attacks, significantly disrupting its services and causing financial losses. The company's cybersecurity team, led by Dr. Sarah Mitchell, decided to leverage AI to combat these persistent threats. Dr. Mitchell's team focused on employing machine learning algorithms to dissect network traffic and detect anomalies that could indicate a DDoS attack. They utilized historical data to train the models, enabling the AI system to recognize irregular traffic patterns. This setup aimed to preemptively identify and mitigate DDoS attacks before they could cripple the network. The primary question at this stage was whether the AI system could reliably detect anomalies in real time and initiate appropriate countermeasures. The AI system was indeed successful in predicting potential DDoS attacks by analyzing traffic data continuously and identifying unusual spikes that deviated from the norm. These anomalies triggered automated responses, such as rate limiting and traffic rerouting, which effectively neutralized the threats. The implementation of AI significantly reduced downtime and financial losses, demonstrating the practical benefits of integrating AI into cybersecurity measures. This success led to an important question: how can other organizations replicate Technova's success using similar AI-powered strategies? While Technova's case illustrated the use of AI for DDoS mitigation, phishing attacks remained a ubiquitous threat. Our next scenario involves Global Bank, a financial institution grappling with sophisticated phishing attacks targeting its employees and customers. The bank's chief information security officer, Michael Lee, decided to adopt an AI-driven approach to enhance email security. Lee's team implemented a machine learning model that scrutinized email features, including headers, content, and sender information, to distinguish between legitimate and malicious emails. The model was trained on a diverse dataset of legitimate and phishing emails, allowing it to learn distinguishing patterns. The critical question was whether the AI could maintain high accuracy in identifying phishing attempts and reduce the incidence of successful attacks. The AI system proved adept at identifying phishing emails, significantly reducing the number of successful attacks. By incorporating natural language processing techniques, the system could analyze email content more effectively, detecting subtle cues indicative of phishing. This raised a pertinent question: what additional measures can organizations take to complement AI-driven phishing detection systems? One of the transformative aspects of AI in cybersecurity is its role in malware detection and classification. This was evident in the case of SoftSecure, a cybersecurity firm specializing in antivirus software. Traditional signature-based malware detection approaches were increasingly ineffective against new malware variants, prompting SoftSecure to explore AI-driven methods. The firm employed deep learning techniques, training a neural network on a substantial dataset of known malware samples. The objective was to enable the network to generalize from this data and identify previously unseen malware. The question that arose was whether the deep learning model could maintain high accuracy and speed in detecting new malware strains. The deep neural network, developed by SoftSecure, demonstrated exceptional capability in identifying new malware with high accuracy. The system's ability to generalize from existing data allowed it to recognize unfamiliar malware patterns, significantly enhancing detection speed and reliability. This success prompted discussions on the optimal ways to continuously update and train AI models to keep pace with evolving malware. Beyond detection, AI's application in threat hunting and incident response offers further advancements. Consider the scenario of DataShield, a cybersecurity service provider. DataShield's team of analysts was overwhelmed by the sheer volume of data they needed to sift through to identify potential threats. The company decided to integrate AI to augment their threat hunting capabilities. The AI system was designed to automate the analysis of logs, network traffic, and endpoint data, identifying potential indicators of compromise. By reducing the manual workload, the AI allowed analysts to focus on more complex and strategic tasks. The central question here was how effectively the AI could augment human analysts and improve overall threat detection and response times. The implementation of AI at DataShield significantly improved the efficiency of threat hunting operations. The system's ability to quickly process and analyze vast amounts of data reduced the time required to detect and respond to incidents, enhancing the overall security posture. This success highlighted the need to explore how AI and human analysts can best collaborate to maximize cybersecurity efforts. Predictive analytics represents another frontier in AI-driven cybersecurity. The case of SecureTech, a cybersecurity consulting firm, illustrates this application. SecureTech aimed to leverage historical data to forecast future cyber threats, enabling proactive defense measures. They utilized machine learning algorithms to identify patterns in past cyber incidents and predict potential future threats. The primary question was whether predictive analytics could provide reliable early warnings of cyber threats and allow organizations to bolster their defenses preemptively. The results at SecureTech showed that predictive analytics could indeed forecast cyber threats with a reasonable degree of accuracy, enabling timely preventive actions. This raised an important consideration. How can organizations ensure the accuracy and reliability of predictive analytics in dynamic cyber environments? While AI offers substantial benefits in enhancing cybersecurity, it is not without challenges. The continuously evolving nature of cyber threats requires the constant updating and retraining of AI models to maintain their effectiveness. This brings up the question of how organizations can efficiently manage and update AI models to keep pace with emerging threats. Moreover, the reliance on large datasets for training AI models introduces concerns about data privacy and security. Ensuring that these datasets are anonymized and securely stored is crucial. The question then becomes, how can organizations balance the need for extensive data with stringent data privacy and security requirements? The case studies discussed underscore the transformative impact of AI in cybersecurity. Technova's success in mitigating DDoS attacks, Global Bank's enhanced phishing detection, SoftSecure's advanced malware classification, DataShield's efficient threat hunting, and SecureTech's predictive analytics all illustrate AI's potential in bolstering cybersecurity. However, these applications also highlight the importance of continuous model updates, data privacy, and the collaboration between AI and human analysts. To address these questions and challenges, organizations can adopt several strategies. For instance, implementing automated systems for continuous model updates can ensure that AI models remain effective against evolving threats. Additionally, employing robust data anonymization techniques and secure storage solutions can address data privacy concerns. In conclusion, AI's integration into cybersecurity frameworks has proven to be a game changer in combating various cyber threats. The real-world applications discussed provide valuable insights into the practical benefits and challenges of AI in cybersecurity. By addressing the identified challenges and leveraging AI's capabilities, organizations can significantly enhance their cybersecurity posture and better protect against the ever-evolving landscape of cyber threats.